So this video will talk about finding the velocity from a position time graph. So there's going to be three things I want to talk about. The first thing I want to mention is that if your position time graph has a straight line, that means that the velocity is constant. If that happens, then the velocity of that object is going to be the slope of the line. So now keep in mind that when you're driving, you usually are not going at a constant velocity. Usually you're speeding up or slowing down. The only exception is if you are driving and you're on cruise control. In that case, you actually are going at a constant velocity. But other than that, you're usually speeding up, you're slowing down, you're going in different directions. So most of the time, you are not at a constant velocity. So we're going to have two other things that we can calculate. So the first thing is the average velocity. So to find the average velocity from any 2 points on a graph, I'm going to specify actually this is on a position time graph because we do have other types of graphs. So to find the average velocity, you are going to draw the line connecting the points and find the slope. This is what we call a secant line. I'll just draw a little picture on the side just so you know what that looks like. So let's say you have, it looks kind of like a parabola type thing. So if you want to find the average velocity between 0 and this point right here, you are going to draw a line between those 2 points and find the slope of that line. That will give you the average velocity there. So I'm going to write. So our average velocity equals the slope of that blue line right there. So the next thing that we have is the instantaneous velocity. And so that's going to be the velocity at any instant. So the average velocity is going to be over time. Instantaneous is at 1 instant. You find the instantaneous velocity by finding what's called the slope of the tangent line. So I'll show you what I mean. So like, let's say we have this point right here, and we want to know what is the instantaneous velocity. What we're going to do is we're going to look at how the graph is shaped and draw what we call a tangent line. It's one that intersects it really only at one point. My graph maybe looks like it intersects it at more, but it should be at one point. So that's going to give you the instantaneous velocity. So for here, my instantaneous velocity here is the slope of this line. So let's do some examples. So first example, we have a position time graph. I apologize, but the title of this, the label got cut off. It actually did originally say position, and it's in meters. So you are standing at position 0. It's always a good idea to specify where 0 actually is. If your cousin is running around, we want to describe her motion, and then we want to find her velocity in several different places. So let's start with her motion. So I'll go ahead and we're gonna describe it over different points, and I'll show you which ones I want to talk about. So I'm going to look at each portion of the graph. There's one other point that's important that we're going to talk about, but we'll start at t equals 0 to t equals 10. So we already said that you're standing at position 0. So basically what's going to happen is that your cousin starts running forward from you for 10 seconds. And in those 10 seconds, she runs 60 meters. I also want you to note that I wrote that your cousin goes forward 60 meters. We know that because the position is getting to be more positive. By the way, if you want to write this as one full paragraph, you are welcome to do this. I like to split it up into different parts. We're going to come back to the velocity in just a moment. I want to talk about the next part. Actually, these were supposed to be 15. Sorry about that. So the next part, you'll notice between t equals 10 and t equals 15, the position doesn't change. That means that your cousin is not moving for those 5 seconds. So then the next part, between 15 and 40 seconds, that's after she started, you can say, if you would rather, it's a more natural way to say it, that for the next 25 seconds. So for that time, your cousin turns around and goes back in the opposite direction. We know that because the position is becoming more negative. You can also look at the slope. The slope is negative at that point. That tells us that your cousin is going in the opposite direction from where she started. So here's the part that gets a little confusing to people. I want you to look at the graph. You'll notice that at time t equals 30, your cousin's position is at 0. Keep in mind that you are at position 0. So actually what is happening is that at t equals 30, your cousin runs past you, and then she goes for another 40 meters behind you. So then the final thing is, once she's 40 meters behind you, she actually is going to turn around again. She is going to go towards you, and after I said to 50, but it looks to me like it's about 54 or 55. Then after 15 more seconds of running, she returns to you. So the next thing that we're going to be doing is finding the slope or finding the velocity at those intervals. So we do that by finding the slope of the line. So to find the velocity between t equals 10 and t equals 0 and t equals 10, we're going to use the slope of the line. So recall from math class that our slope is our change in y, or y2 minus y1, over our change in x, or x2 minus x1. In this case, we actually don't have x and y, we have position and time. So you're going to be having to look at the graph, just figure out what the points are from the graph. So in this first part, I start at 0, 0. My next point is at 1060. You can just work it out like that. I also have another point right here at 1560. And then I have a point at 40, negative 40. So I can use those to help me find the slope of the line. So to find my velocity, I am going to be finding the slope, for the first part, the slope of the line between t equals 0 and t equals 10. So that slope, my m, which remember is my velocity, is going to be equal to 60 minus 0 over 10 minus 0. That is actually going to be 6. Now, in physics, whenever we find a slope or anything else, it's important that we keep our units. Otherwise, it doesn't really have a lot of meaning. So our position was in meters, our time was in seconds, so it is going to be in meters per second. If you want, this might make it easier on some of you, you can actually write in the units when you work out the problem. You will find that you get 60 meters over 10 seconds, which gives you 6 meters per second. If you find the slope of the line between t equals 10 and t equals 15, actually it's going to be 0. You're not moving at all, so it makes sense that your velocity is 0. I'd like you to find the last slope on your own, the between 15 and 40. I'll write down the work in just a second, but please pause the video and find it. So I end up getting -4 meters per second. The negative is actually really important because velocity is what we call a vector value. Vector means that it tells us the direction. So the negative is going to tell us that our direction is going to be in the backwards direction, meaning it's not the same as, it doesn't mean that your cousin necessarily is running backwards. It just means that she's running in the opposite direction from where she started. So for this second example, I gave you a graph of the motion of your cat. Now, I don't know how many of you have a cat, but if you have a really energetic cat, they don't always run at a constant velocity. Sometimes they act a little crazy. So, first thing in this case, you'll notice that the first thing I asked you to do was describe the motion in words. So we're going to assume that at 0, that's where you are. Now, this is a cat, not a dog, so your cat doesn't want to hang out near you unless you have a really nice, friendly cat, which every cat I've ever had has not been nice and friendly. So your cat actually is starting 1 meter away from you. That's what I first want you to notice. The next thing that happens is your cat goes forward for 2 seconds. Then your cat is going to turn back around. So at time 4 seconds, your cat actually is going to pass you and then go behind you. So keep in mind the negative position here is going to be the space behind you. So the cat is running forward, turns around, runs past you, and runs behind you. Okay, so first question I asked you to do was calculate the average velocity from t = 1 to t = 4. So when we do that, what we're going to do is we are going to put a point at t = 1. We're going to put a point at t = 4. You can assume that that point is 4, 0, even though it looks like it's a little bit in front of it. And then we're going to find our average velocity. We do that by finding the slope of this line right here. So this is for part B. We're going to find the slope of that line. You can pause the video and do that, by the way, if you'd like. So this point here is 1, 3. This point right here is 4, 0. Something that is really helpful for many people is to keep in mind what the x represents and keep in mind what the y represents. So our x, in this case, x = 1, x is time, it's going to be in seconds. This 3 is our y, which is our position. By the way, you'll notice this part confuses people a lot. Sometimes you'll see position referred to as x. If this is really confusing to you, you can just cancel it out, because in math we usually use x and y, but in physics x is actually usually position. So feel free to just write position there. So that 3 is going to be my position in meters. You can do the same thing with this 4 and 0. The 4 is in seconds, the 0 is in meters. So for part B, we are going to find the slope of the line. Slope, remember, is change in y, or y2 minus y1, over change in x, which is x2 minus x1. So in this case, my velocity, my average velocity, is going to be my change in y, so it's 3 meters minus 0 meters, over my change in x, which is going to be 1 second minus 4 seconds. If you calculate this out, you get 3 meters over -3 seconds, or -1 meter per second. So for part C, I asked you to calculate the average velocity from 1 to 3. That one actually is a little bit less fun, because at 3, to me it looks like that point is about 3, 2.5. This point here was 1, 3. So you do actually have a 1, you do have a decimal in that. So I want you to try that one on your own. Pause the video and do that. And you should get that your velocity there is about negative 0.25 meters per second. So for part D, I asked you to calculate the instantaneous velocity at t equals 2. That's where we do what's called the slope of the tangent line. At t equals 2, you'll notice that's like my vertex of my graph. If you have a point like that, your tangent line is actually going to be a straight horizontal line. So I want you to think about this. What is the slope of that line? If you thought 0, you are correct. Actually, at this point, the instantaneous velocity is 0 meters per second. When your cat is turning around, it's not actually running. It's momentarily not moving at all. So for that instant, the instantaneous velocity is going to be 0. The last thing that we're doing is instantaneous velocity at t equals 4. That one's a little bit harder. So for this next part, you only really need to know how to do it if you're in the honors class. If you're not, then you can just, you can watch this if you're interested, or you could kind of skip watching it at all. So we're going to be drawing a tangent line right here. So this line is not perfect. I did the best I could with the stylus. I'm thinking that probably my tangent line has a point right here at 3, 3. And I'm going to guess that the other one is approximately at 5, negative 3. So my instantaneous velocity at t equals 4 is going to be the slope of this line. Go ahead and find that on your own, please. So the instantaneous velocity is approximately negative 3 meters per second. The reason it's negative is because your cat is going in the opposite direction from where they started. So that is going to be your instantaneous velocity there.